Well, question number 2, the line L1 has equation R is equal to I plus 3j minus k plus lambda into I minus j minus 4k, and the plane pi is equal to, the plane pi contains the line L1, and of course now what we have is also that line is parallel to the vector 2i plus 5j minus 4k. So we need to find the equation of pi of the plane, giving your answer in the form of ax plus by plus cz is equal to d. Now the way we're going to go about and do this, first of all, I'm just going to do a small illustration here, and let's try and see. This is maybe our plane. We have a line in here, the line L. It has a coordinate, and this is the coordinate here, 1, 3, minus 1. And we have 1, 3, minus 1. That's the coordinate on the line. Also, the line is parallel to a line that has a vector equation 2i, which is 2, 5, and then minus 4. And at the same time, this here has a direction. Okay, the direction of this line, of this vector line in that plane, is 1, minus 1, and then minus 4. So now how are we going to go about and find the equation of the plane? So we're going to use the cross product of the matrix, cross product of the vectors. So by cross product, the cross product here, I'm going to take the two direction vectors, multiply by each other. So we have then 1, minus 1, minus 4 being multiplied by 2, 5, and then minus 4. Now, if I cross this one here, I'm going to get minus 1 times minus 4, which is 4. 5 times minus 4 is minus 20. And so I've got then 4 minus minus 20, which is then 24. Now, if I cross this one here, like it doesn't exist, I'm going to get 1 times minus 4, which is minus 4. 2 times minus 4 is minus 8. And minus 4 minus 8 is minus 4 plus 8, which is 4. And now I'm going to cross this one over here, and I got those to 5. Minus minus 2 is then 7. And of course, you're going to say this one is plus, this is minus, and this is plus. The next thing we're going to do is we're going to try to substitute the point, the coordinate we talked about earlier on, into this equation here. So this equation turns out to be then 24, we've got 24x minus 4y and then plus 7z. That is going to be equal to d. So if I were to substitute this point here into that equation, I'm going to get 24 times 1 minus 4 times the y coordinate is 3 plus the 7 times z. The z coordinate is negative 1, and all that is going to be equal to d. Turns out that d is going to be equal to then 5. So the equation of the plane pi is then in that form, ax plus by plus cz turns out to be 24x minus 4y plus 7z, and that's going to be equal to 5. So this is our answer to the first part of the question. Second part of the question, we need to find, we've been given the line 2 is parallel to this vector. We have a line 2 here, and we need to find the equation between this line 2 and the plane. Now let's suppose that this is a line, it could be this one here, it's parallel to another line which has this vector here. So I want to find the equation, of, the angle between this line 2 here and the plane pi. So here we've got 5, minus 5, and minus 2 in the direction of that other vector over here. So how do we go about and do this? Now, first of all, I need the equation of the plane, which is 24x minus 4y plus 7z is equal to 5. The direction vector of this plane is is 24 minus 4 plus 7. So we have 24 minus 4 and then 7. I'm going to take that and I'm going to dot product with the direction vector of this line here, which is parallel to the other line too. So that's 5 and then minus 5 and then minus 2. And if I were to dot product here, it turns out to be 126. I'm sure you know how to do this. 24 times 5 and then plus 4 times 5 and then plus 7 times minus 2 turns up to 126. And so from here we're also going to find the magnitude of each of these vectors here. Okay, so just to make it fast, right, okay, so, and as can be seen, you know, if you were to find the magnitude of each of these vectors, you're going to get this. Now we can apply the formula. So we know that cos of theta by definition is equal to vector A times vector B, vector A dot vector B over magnitude of A times magnitude of B. So this turns out to be then 126 divided by this product of these two lengths over here. And if you were to do this in a calculator, you should be able to get 0.67772 something. And so we have then theta is going to be equal to cos inverse of 0.6772, 0.6772 that I should have said. And do this, theta turns out to be 47.37 degrees, but we're looking for the acute angle between them. So I'm going to say the acute angle of theta is going to be equal to 90 minus this 47.37 degrees here, makes it then 42.62, 3 significant figures. So this is the second question from the Further Maths paper code 9231 2024, and then paper 1 here. Take care.